Okay, cool. So yesterday we started applications of the definite integral, and for the most part you guys did a pretty good job with that. The problems though tended to be maybe a little bit obvious what you were supposed to do. Today's going to be far less obvious. If all goes well, we're going to knock out these next 3 questions in about 25 minutes. My goal was to write really hard questions. Harder than what I'm going to ask you to do tonight for homework. Harder than what we did yesterday. But give us the opportunity to do it like together in a safe space. So before you freak out, I'm on page 21. Know that these next 3 questions are going to push you in new ways. And it's okay. Alright, we got a function f of x which satisfies the condition that f prime prime, what is that really? F prime prime?
Double prime.
F double prime, and F double prime means second derivative. F double prime is equal to e to the 4x plus e to the negative 4x. F prime of 0 is equal to 4, and f of 0 is equal to 4. I'm starting you down here with f double prime, and I want you to get up there to f. So just have a strategy conversation with the folks around you. What are you going to do? What's your plan? Once you've got a plan, take action. Alright, you're starting at f double prime. You want to get to f. I'm seeing a whole lot of folks making some good choices here. What are we going to do? How do you go from f double prime to f? What's the strategy here? Right, we're used to going in this direction where what you're doing is you're going to take a derivative, right? If I gave you f and said f double prime, you take a derivative twice. I need to reverse that process, and that's where the antiderivative comes in. So f prime is going to be the integral of e to the 4x plus e to the negative 4x with respect to x. And I would hope now that it's written, it's obvious what the answer is. Right? What's it going to be? Integral of e to the 4x. Everybody knows this one. It's not e to the 4x. Pull out that foldable if you need to. The integral of e to the 4x is 1/4 e to the 4x. The integral of e to the negative 4x is negative 1/4 e to the negative 4x. Are we doing a definite integral or an indefinite integral?
Indefinite.
It's an indefinite integral, so you guys know we need
Charlie.
plus c. What this is right now is f prime. You're not done. Your goal is to get to f. We know f prime has this form. We haven't figured out what Charlie is. Do we have any information that we can use to get to Charlie? Right, they gave me this fact that f prime of 0 is equal to 4, and I like to call that the initial condition. So if f prime of 0 is equal to 4, that basically says that if x equals 0, then f prime is 4, negative 4. So plug in 1/4 e to the 4 times 0 minus a 4th e to the negative 4 times 0 plus c. All that is supposed to equal 4. So what's c? 4 times 0 is 0.
1/4.
E to the 0, that's 1, right? So you've got a 4th minus, what is that, a 4th over there? Plus c is equal to 4. What do we get for c?
4.
C should be 4. C's not your final answer. C's part of the problem. F prime now, you can say with confidence, is 1/4 e to the 4x minus 1/4 e to the negative 4x plus 4. Please don't stop there. You need to get to f. How are we going to get to f?
You find out.
Jose, what was that? we're going to find the antiderivative of f prime, right? We need to go up one more link in the chain. So to get to f is the integral of 1/4 times e to the 4x minus 1/4 times e to the negative 4x plus 4. X is the variable, so I'm integrating with respect to x. Got to go find the antiderivative again.
Isn't that F prime?
What would give me a derivative of 1/4 times e to the 4x? F is the antiderivative. If you're not sure, cover up the 1/4. The 1/4 is just multiplying, right? So what is the integral of e to the 4x? That's supposed to be 1/4 e to the 4x, but I've got this 1/4 in front that I have to multiply by. Then I've got minus 1/4. Integrate e to the negative 4x, you get negative 1/4 e to the negative 4x. Plus I need the integral of 4x. And be careful. That's pretty good. It's not all the way good. We just did an integral. You just did an indefinite integral. The problem? This is not going to be all the way right because we haven't figured, like you haven't added on that constant. Now the thing is, a lot of folks, and this came up last period as well, everybody says plus c. Here's the problem with using c right now. You've already used it once before in the problem. You don't want to use c again. Because anytime you write c, I'm going to say, oh, you mean c is equal to 4. We don't know that c is equal to 4, so don't talk about Charlie. Talk about somebody else. Kevin plus k plus d. It doesn't matter. Some other variable here. So if I clean this up, f is 1/16 e to the 4x plus 1/16 e to the negative 4x plus 4x plus k. You still have to go get that constant of integration. So we're going to use the other initial condition. If x is equal to 0, f is equal to 4. So plug it all in. 4 is 1/16 times e to the 0 plus 1/16 e to the 0 plus 4 times 0 plus k. All you need to do is figure out what k is. E to the 0, that's still 1. Times the 16 is 1/16 plus another 16 plus 0 plus k. I want to get to k. What you might do, right? I love killing off those fractions. The fractions are going to get in our way. So how are we going to kill off the fractions? What are we going to do to get rid of those fractions? You've got an equation that involves fractions. That fraction killer trick that we talked about is you multiply by the common denominator, which in this case is 16. The reason that it works, 16 times 4 is 64. 16 times 1/16 is 1. 16 times 1/16 is 1. 16 times k is 16k. You've got whole numbers. This is a much easier process now. 1 plus 1 is 2. Subtract it from the other side. Divide everything by 16. You're going to get that k is 62/16. And if you want to simplify, it's 31/8. Bad board planning here. Your final answer is 1/16 e to the 4x, 1/16 e to the negative 4x, plus 4x plus 31/8. My goal was to write some really tough questions for us to experience together. The homework tonight is not going to be this ugly. not. All right, is everybody caught up with the writing?
Yeah.
All right, time for another push. Next problem, problem number 3. We'll talk in a minute.
Mr.
Yeah?
That was right.
Find the exact positive value of c if the area between the graph of y equals x squared minus c squared and the x-axis is negative 36. Problem number 3.
The x-axis between the graph of y and the x-axis.
So that I was multiplying the equation by 16 to get rid of all fractions.
I don't have time. Yeah.
Find the exact positive value of c if the area between the graph of y equals x squared minus c squared and the x-axis is negative 36. Anybody know what the graph of y equals x squared minus c squared looks like?
No.
Is it the c squared that's messing everybody up?
Yep.
So put in a number just for a second. So let's c be 5. What is that graph? Y equals x squared minus some number squared. What does that graph look like? You've got a name for it. Delia knows exactly what it looks like. One more time. It looks like that. Y equals x squared minus stuff is just a parabola. Well, it's a parabola that's been shifted. Which way? It gets shifted down. So I've got my regular parabola that's been shifted down. Here's the graph of y equals x squared minus c squared. And the area between the graph and the x-axis is negative 36. We're in a calculus class. We're talking about area. How do we find area? How do we always find area? Nobody on that one?
Integral.
Integration. That's what a definite integral means. So we're going to do a definite integral of x squared minus c squared with respect to x. And you need to get negative 36 as your answer. The problem, though, what are your limits of integration? Where do you start integrating? Where do you end?
You don't know.
You don't know. I didn't give it to you. But you have the graph in front of you and some really good math instincts. What is it that you need in order to figure this out? Look at the graph. What's the thing that you need? There's a name for what you need.
Isn't it supposed to be infinite? So it's going to be n?
Well, it's not infinite, right? There is a place where we start integrating, and there is a place where we stop integrating. And those things are called the roots. So this is a limit, and that's going to be a limit. It's the zeros, right? The roots are the zeros. So you've got to ask yourself, where is x squared minus c squared equal to 0? Well, if x squared minus c squared is equal to 0, that's the same thing as saying x squared is equal to c squared. So the x value that I want is going to be plus or minus the square root. So x is plus or minus c. You've got a root over here at c comma 0 and a root over here at negative c comma 0. You're going to integrate from negative c to c. Those are your roots. Even if you weren't okay with getting the roots, what are you going to do now? I hope you're not just going to plug in, Jose.
So you're going to plug in C?
Don't plug in C. You have to first find the antiderivative, right? The calculus notation is telling you what to do. You need to find the antiderivative of x squared minus c squared. X is the variable. Once you do that, you're going to plug in the c and the negative c. Get going, see what you can do with this. What's the integral of x squared minus c squared? C is the constant, not 2x. We're integrating. Integrating, exponents go up. Okay, the integral of x squared, add 1 to the power, divide by the new power, 1/3 x cubed, minus the integral of c squared with respect to x. C is a constant, like 3, 7, 12. What's the integral? I saw it on 3 papers. It's not 0. That would be the derivative.
1 over c.
What do you take the derivative of to get c squared?
C squared.
It would have to be c squared times x. And now you're going to evaluate from negative c to c, and you need to get negative 36. That's the antiderivative. You've got to evaluate at negative c and c, which means, Jose, finally we're at the plug-in part. Everywhere there was an x, you're going to plug in c. Everywhere there was an x, plug in negative c.
But you don't know what negative c is.
You're right, you don't. But let's just keep going here. Okay, big parentheses minus big parentheses, c gets plugged in first. 1/3 c cubed minus c squared times c. In this next one, it's 1/3 of negative c cubed minus c squared times negative c. We don't know what c is, but we're going to find it. All this stuff minus all that stuff is equal to negative 36. There's no more calculus to do. What I need is your algebra skills now. Any legal algebra that anybody sees that might be helpful here. You want to combine the c's? What do you mean? Okay, c squared times c, we have a better way to write this. That's going to be c cubed. So we've got 1/3 of c cubed minus c cubed minus, how about that second parentheses? 1/3 negative c, the whole thing gets cubed. Negative c times negative c times negative c. Should be positive or negative?
Negative.
Negative c cubed times 1/3. So that's negative 1/3 c cubed. Negative c squared times negative c is positive c cubed. We still have to figure out what c is. Need some cleverness here. Bento, what do you got?
Distribute negative.
Okay, is that legal?
Yes.
Okay. So if you distribute, now like once you distribute, I'm going to get rid of the parentheses over here, so I'm also going to get rid of them over here. So I've got 1/3 of c cubed minus c cubed plus 1/3 of c cubed minus c cubed is equal to negative 36. Everything is c cubed. This is good for us. Unfortunately, you've got fractions that you've got to deal with. That may not be so good for us. Any thoughts on what you could do? If you want to start combining, that's fine, but now you get the fractions, and somebody's going to get messed up on the fractions. Maybe you want to try factoring. Maybe you see all the fractions and you think, gosh, in the last problem we ran into a problem just like this, and the key was multiply by the common denominator. Multiply everything by 3. You don't have to, you can deal with the fractions. 3 times 1/3 c cubed is c cubed. 3 times negative c cubed is negative 3c cubed. 3 times 1/3 c cubed. 3 times negative c cubed. 3 times negative 36 is negative 108. This should be a much more likely problem for us to get right because we get rid of all the fractions. I'd look to combine like terms at this point, c cubed and a negative 3c cubed. is that negative 2c cubed plus c cubed. Hey Juan, how you doing? C cubed minus 3c cubed is negative 2c cubed. Plus c cubed is negative 1c cubed or negative c cubed. Minus 3c cubed is negative 4. C cubed equals negative 108. Everybody knows what to do now. You're going to divide everything by negative 4. So c cubed is 27. What cubed is 27? 3. My goal was to write some really tricky questions. I think Nahum would say, mission accomplished. All right, one last one. I want to see what you guys can do with this. Okay, I'll leave this up here for a little bit. Problem number 4, let f be the piecewise defined function shown below. Determine the average value of f on the interval negative 1 to pi. Do not worry about simplifying your final answer. Delia, you're going to be okay, I promise. No one's brain has ever actually exploded in class. We've had some close calls, though. Is everybody good with the notes? Okay. The average value for f of x. Indeed. Oh, no. No. You're missing a really important part. It's getting closer. It's getting closer. Average value. That was last unit, but we also dealt with this yesterday. Average value is 1 over b minus a, the integral from a to b of f of x dx. Your setup, well, a is negative 1 and b is going to be pi, so this should be 1 over pi minus negative 1. And we've got to do an integral from negative 1 to pi of f of x. And now here comes the tricky part. What's f of x?
Isn't it x plus 1?
It's x plus 1? It's both?
It's
both.
It is both.
It is both. But I want to find the integral from negative 1 to pi. I have to start all the way over here at x equals negative 1 and get all the way over to pi. But what happens is the function changes on me halfway in between. So to get this integral, and I heard this from Kaylin and some others, you're going to have to split this up. You know what the function is until you get to 0. Well, it's just x plus 1. But then at 0, it switches to now 1 plus sine of pi x, I think. And all that gets multiplied by 1 over pi plus 1. This is why I didn't want us to worry about simplifying. The calculus left to do, you need to find the antiderivative of x plus 1. You need to find the integral of 1 plus sine pi x. Let's take a minute to test out those integration skills. What's the integral of x plus 1? Integral of x plus 1, just saw it on a couple of papers. Hold on. Is 1/2 x squared plus x. Hopefully that part not too bad. Okay, we need to evaluate that from negative 1 to 0. We clearly don't have time for that. Plus, now I need the antiderivative over here. What has 1 plus sine pi x as its derivative? 1x. Then I need to find the antiderivative of sine something times x.
1 over.
It's negative 1 over pi cosine pi x from 0 to pi. I just want to get parentheses in the right place. You need parentheses here on this part, because you're going to evaluate at pi, you're going to evaluate at 0. You need parentheses here, so that you evaluate at 0 and -1 correctly. And you need one more set of parentheses.
All of it. Right?
Because all of this gets multiplied by 1 over pi plus 1. There are no problems like this on tonight's homework. I'll see you guys later. Thanks, Jackie.